the kerosene. All the data are given. So in this equation, we have to calculate the value of U, that is the overall heat transfer coefficient. Okay, so here we need to apply the knowledge of heat transfer, and for that purpose, overall specific area is given. A is given as 13.5 meter square. Is given as 13.5 meter square, that is going to be mentioned. U is equal to A, that is mentioned as 13.5 meter square. So this value is mentioned, and for that we have to calculate the value for Q. So initially we need to calculate the value of Q. Then you have to use this equation, UA delta T LM. Okay, I will go with the white screen. Okay, we have to use this equation. Q is equal to UA delta T LM. Okay, then we have to find out U from this. Okay, but Q we need to calculate using mCp delta T within this equation of m dot Cp delta T, assuming sensible heat is going to be transferred. Okay, temperature data is given means this one. So once we know how to calculate Q, but what for that we need to calculate initially what is delta T LM. Okay, delta T LM, that we need to calculate it here. LMTD delta T1 minus delta T2 entire term divided by ln of delta T1 upon delta T2. Correct? Okay, I hope you understood this. So using this, we have to calculate this particular value. Okay, so likewise, I will go to the slides. Okay, so that we have to calculate. Now let us see the solution of that. Okay, all the data are given. So here we have delta T1 is equal to 150 minus 135, because the temperature what we have mentioned 135, 155. So 155 to 135 and 200 to 150, that can be the another flow. Okay, so 155 minus 135, that is 15. Delta T2 will be equal to 200 minus 145, that is equal to 55. Okay, and that's why LMTD is equal to delta T1 minus delta T2, that is ln of delta T1 by delta T2 into 55 minus 55. Okay, ln 55 minus 15. Likewise, that will be mentioned. So the total rate is coming to be 30.75 or 30.78 degrees Celsius. Now we have calculated LMTD. Okay, now the next thing is we have to calculate the Q. Okay, for calculating Q, what we require mCp delta T, right? mCp delta T. So within that we have to find out Q will be equal to, let us consider for crude oil itself. Q will be equal to mCp delta T, that is 20,000, 20 tons per hour was given, right? 0.53 CPC. Then TC1 minus TC2, that is 145 minus 135, that is 106 kilocalorie per hour meter square. Okay, 106,000 kilocalorie hour per meter square. Now this is equal to, now this we can set equal to this equation. Q is equal to UA LMTD. We know the LMTD, we know the area E. From that we have to calculate the value of U. Okay, so U will be equal to Q divided by A into LMTD. So here another note we can note it. Now here it is not specifically mentioned that area is given for outside or inside. We are assuming that inside and outside area are both are same. So values of overall heat transfer coefficient U will be same for both the sides. Okay, that we have to assume it here across this. Okay, so this was U. Okay, so U will be equal to Q divided by A into LMTD. Q divided by A into LMTD, that will be using this particular equation. So that is 1.06 into 10 raised to 5 into 13.5 into 30.78. So answer will be coming 255.1 kilocalorie per hour meter square degree Celsius. Per hour meter square degree Celsius, that is the final answer, which is going to be there. So such a questions may be asked for an example for 8 marks. Okay, 2 marks will be there for this calculation, 3 marks will be there for Q calculation, and 3 marks will be there for this one as per the rubrics of that. Okay, I hope that you have understood this. If you have any query, you can put it into the chat box or you can put it into the comments so that we are able to answer the solutions, or you can ask in the online classes or Monday or Tuesday. Okay, so this was regarding particularly this particular the heat exchanger through heat pipe steel heaters. Now next is the pipe steel heaters. Now here you can see this is a proper example for the pipe steel heaters, that in these pipe steel heaters it consists of two sections. One is the radiant section, another one is convection sections. So burners are attached at the bottom to create the radiant energy. Okay, and the vertical flames, okay, are going to receive to the heat. So sometimes crude oils are also heated in heaters. Okay, so oil which you want to heat it, that is going to enter through the tubes which are provided in the convection section, and it flows in the this particular directions. So when it flows from upward direction to the downward direction, it receives the heat in two forms. One in the form of radiations through the radiation tubes, and another is in the form of convection zone. So steam is going to enter into the seal. The steam is condensed outside the tubes, and this steam is going to leave through the gases. So here, the flue gases which are generated because of the flame of the burner, they are also going to provide a certain amount of heat to the oils. Because of that, the oil is preheated into that particular surface. The oil is get preheated into that particular surface. That's why the tube steel furnaces may be also used as the reactors, may be used as a vis breaking furnace, may be used as a coking furnace, pyrolysis heaters in the olefin productions. Okay, and these preheated oils are either charged to the atmospheric distillation or they have been charged to the vacuum distillations as a raw crude oil, RCO. They have been charged as a raw crude oil, RCO, for that particular course which will be available. Now just let's go through the vacuum distillation. Okay, so here you can see the particular flow diagram for vacuum distillation. So in vacuum distillation, the raw crude oil from that particular stage or the product from atmospheric distillation unit, that is initially heated into the, initially it is stored into the surge drum. Okay, so it is initially stored into the surge drum, and when it is stored in the surge drum, it is pumped through the various kinds of the preheaters. So remember, the product may come from the desalting unit or the product may come from atmospheric distillation unit. As I told, in atmospheric distillation, here if some of the products, okay, remain as untreated at the bottom of atmospheric distillation, then these are charged to the vacuum distillation for further treatment. And for that, and then again, after passing through the preheaters, they enter into the pipe steel heaters where they are heated up to the temperature which is ranging from 350 degrees Celsius to near about 370 degrees Celsius. And this RCO, raw crude oil, is charged to the fourth plate of the multi-component distillation column. Fourth plate of multi-component distillation column. And as it goes in upward direction, the separation occurs because of